Greetings, everyone. Let's start solving some vector problems from some old AP exams so you get a sense of how the questions are asked and what's expected of you. So this is from a long time ago. An object moving along a curve in the xy plane has the position function given by x of t, y of t. So they're telling you it's a vector, moving in the xy plane. They're giving us the representations of the horizontal and vertical components for t greater than or equal to 0. They're giving us dx over dt is 3 plus cosine t squared. The derivative, dy over dt, is not explicitly given, so we don't know what dy over dt is, and we still have to solve some problems here. Time t equals 2, the object is at a certain position. So just to note what that means, so they're telling us that x of 2, and I put t, x of 2 is 1, and y of 2 is 8. Okay, so that's just how you want to interpret that. First, it says to find the x-coordinate of the position of the object at time t equals 4. All right, so not every time, but almost every time they give you a vector problem or even a parametric equation problem that's less directly a vector, they tend to give you a sub-problem, one of the A, B, C's, or D's, one of the sub-problems that's in one dimension only. Okay, and that's what this part A is about. All we care about is the x coordinates. Nothing about y matters for part A. This is now an A, B level question. It's not even BC anymore. The problem is a lot of people don't see it that way, and then there comes an issue. This is really just a fundamental theorem problem. Okay, we know the derivative. We know x prime, or dx over dt. We know x of 2 is 1, and we want to know the position at 4. So what I want to do is I want to write an integral from 2 to 4. Why? Because I know what's happening at 2. I want to know what's happening at 4. So I'm going to write this from 2 to 4 of x prime of t dt. Now I know what x prime is, but I'm not going to put it in there first because I'm trying to teach through this video here. If I was writing this down in a solution that I was just going to present to somebody else to read, I wouldn't bother to do this step. By the fundamental theorem, by the way, this is a calculator active question, which is going to be relevant in just a moment. But by the fundamental theorem, this is going to be x of 4 minus x of 2. Now they told us that we're looking for x of 4, so that's going to stay that way. They told us x of 2 is 1. Now this side over here, I'll write it out this time with the derivative 3 plus cosine t squared with respect to t. Make sure I did that right. Yeah. Now we just got to solve for x sub 4, or x of 4, excuse me. So that x of 4 is going to be 1 plus this integral. Again, this is a calculator active question, which means you just go over to your calculator and type in all of this stuff on the right-hand side, and that's going to be the answer to the question. I'm going to pause the video and go do that in Desmos, and then I'll come back and write the answer down. All right, when you go type this into your calculator, you get 6.13299. So remember, we got to go to 3 decimal places either by rounding or truncating, cutting off. So you can cut off all the 9s and put 7.132. That's acceptable, or round the 2 in the third digit to a 3, and then that's also acceptable. So this question here is, in part A, is strictly an A-B understanding of the fundamental theorem and being able to pull the right information out from this problem. So look for that on these types of problems if they happen to be there this year on the AP. For letter B, it says at time t equals 2, the value of dy over dt is -7. Write an equation for the tangent line to the curve at the point x sub 2, y sub 2. So at the point 1, 8. Now this is where we get back into it being a parametric. Thinking about this as parametrically as opposed to as a vector. So as we learned from our parametric notes, dy over dx is equal to dy over dt divided by dx over dt. Okay, and we need dy over dx to write the equation of the tangent line. I need the slope in the xy plane, so I need dy over dx, and I need the point. I got the point, it's 1/8. Now I just need the slope at, I don't even remember where, at t equals 2. And so I'm going to evaluate this at t equals 2. And what did they tell me at t equals 2? They told me that dy over t is -7, so -7 on top. And then I know dx over dt is this 3 cosine t squared, 3 plus cosine of t squared. So this is going to be 3 cosine of 4, making sure you're in radian mode. Okay. And then we just go plug that into the calculator and then write the equation. They probably would accept this as the answer. So -7 over 3 plus cosine of 4 times x minus 1 plus 8. Because remember, we're doing this at the x of 2 comma y of 2, which is 1 comma 8. So that's it. But I'm going to go get this as an approximation. I'll be right back. All right, so ran that through Desmos real quick to get that. So part A in this example, and an AB level question. Part B, this is a BC level question, but it doesn't really require very much BC skill, just knowing that this is how you calculate your derivative. They gave you the numerator, you had to calculate the denominator and write the equation. Not a challenging question. For C, find the speed of the object at t equals 2. Now remember, we're in 2 dimensions now. And so the speed is the magnitude, speed at t equals 2 is the magnitude of the velocity. Now this is a vector at t equals 2, which we did get by the Pythagorean theorem. So this is going to be x prime of 2 quantity squared plus y prime of 2 quantity squared. All right, so I got to go calculate a couple things. Well, I know that y is 7, -7, y prime of 2 is -7, so this is going to be 49 over here. I guess got to go get what x prime of 2 is, because I didn't do that separately, and then plug that in. So you go type those in, you should get those values, and that's it. That's for the acceleration vector. I'm gonna go find another problem. I should have set up 2 problems, but I didn't set up 2 problems. I must have find another problem, so I'm gonna pause, come back, we'll do another problem together. All right, here's another. At time t, the position function of a particle moving in the xy plane is given by the parametric equations x of t and y of t. So still talking about motion, 2 dimensions. It's a vector problem. They give us dx over dt. Again, graph y consists of 3 line segments that's shown in the figure above. So this is different for the y coordinate. And that is the y coordinates values there. That's not the derivative, okay? Because it's, yeah, it says y of t at the top of the vertical line there, vertical axes. And then it says at t equals 0, the particle has position 5, 1. And so, sorry, x of 0, actually I'm not going to put it as an ordered pair. X of 0 is equal to 5, y of 0 is equal to 1, something to note. And then part A, it says find the position of the particle at t equals 3, okay? So now we're looking for the position of the particle. That means we need its x coordinate and y coordinate. So this one here is not a one-dimensional problem, but, yeah, it's not a one-dimensional problem because you have to do this in the x direction and the y direction, but technically each piece is just an AB problem. Okay, so I think this is a calculator question. Yeah, it's a calculator question. So to find x of 3, I'm going to use the fundamental theorem like we did in the last example. So this is going to be x of 3 minus x of 0 I know x of 0 is 5. I'm going to do this part on the calculator. And so x of 3 is going to be 5 when I add that over, plus the integral of, let's see, it's t squared, integral from 0 to 3 of t squared plus sine of 3t squared dt. I'll have to go plug that into a calculator, and I'll do that in a minute. And y of 3, actually, let me leave this here. X of 3, I'll put that as a placeholder right there. How about y of 3? Didn't they tell us the graph of y of 3 is y is above? So can I just go look at y of 3 right now from the graph? Yeah, I should be able to. I need this value right here. The slope is 1/2, okay, because you rise over run, and we're at -1 here, and so we're going to go, up 1 and over 2, or we're going to go up 1/2 and over 1. So this is going to be at -0.5, -1/2. And then I just got to go run and calculate this in a calculator. I'll be back. I think it's 14.37. Yeah, I'm no longer typing them into the calculator. I'm just getting them from solution guide, but it's still correct. All right, so the position at, if you want to call the position S, the position at t equals 3, not 0, is given by 14.377 comma -1/2. I guess we should use an approximately equal to sign here. I keep feel like I'm getting bit by mosquitoes, but I don't see any. All right, for part B, find the slope of the tangent line to the path of the particle at t equals 3. All right, so we should know that the slope is dy over dx, which is dx over dt. Nope. I don't know why I keep going there first. It's dy over dt divided by dx over dt. And we need to evaluate this at some value of t that I don't remember. T equals 3. So I need the slope of the graph of y at 3. Okay, it's the slope right here. We already said the slope was 1/2. It's going up 1 over 2. So this is 1/2 here. And then we need the slope of x, or the value of x prime at 3. So that's just the derivative that they gave us evaluated at 3. So I'll go get that number and put it into our solution. I don't know why I keep telling you guys when I'm leaving. I'm just going to pause, and for you guys, it's a smooth transition, relatively speaking. But anyway, when you plug in 3 into the dx over dt they gave us, you get this 9.956376. Make sure you use enough decimal places, ladies and gentlemen, in your intermediate calculations. Don't round that to 3 decimals. If you do, your final answer might be off by enough to change this digit. And if it is, I didn't try, but it might be. Sometimes it is, and you don't want to risk missing it because of too easy rounding. All right, part C, find the speed of the particle at t equals 3. So speed at 3, that's going to be Pythagorean theorem. It's going to be x prime of 3 quantity squared plus y prime of 3 quantity squared. And take the square root of that whole thing. Actually, before I do that, I'll just put that there. That's fine. We already calculated y prime of 3. That's 1/2. Okay, so I'm just going to write that in here for visible sake. Okay, so this is 1/2. We already calculated that part. X prime of 3. Oh, we calculated that too. That's that 9.95 that we saw up there. So just run the numbers, and you'll be good to go. So 9.968 or 9.969, depending if you round or truncate. Now for part D, find the total distance traveled from t equals 0 to t equals 2. Okay. Now let's go look at y really quickly from 0 to 2. From 0 to 2, we have y prime, which we're going to need here. Okay, and then we're going to have y prime here. So it changes from 0 to 1. The value of y prime changes it's -2 from 0 to 1, and then the slope is 0 after that, between 1 and 2. So we're going to have to write two separate integrals for this to make sure we do this properly, because we're going from 0 to 2. Okay, so remember the total distance an integral from 0 to 2, just in general would be this, okay? And it's the integral of the speed, really, x prime of t quantity squared plus y prime of t quantity squared dt. But again, because y prime changes definition, I'm going to have to write two separate integrals for this. So I'll write one from 0 to 1, which is going to have, well, x prime of t is going to be the same function that we have above. And on this interval, I think I said this was -2. And then from 1 to 2, I'm going to write it for effect, but I wouldn't normally need to write 0 here, but I'm going to write 0 squared just because, you know, I want you to know that that's what's happening, even though it doesn't need to be written necessarily. And then we're just going to run that through a calculator. When you go run that through a calculator, you get either 3.349, or the digit after the 9 is enough to round it up, but don't. Somebody's going to bump the 4 up to a 5 and then put the 0. Do not leave the 0 off. I don't want them to mark your answer down because you lazily thought, oh, I don't have to write a 0. You do, because it was a rounded number. Okay, so you definitely want to write it down. All right, I hope that was helpful. Request more of these, I guess, if you want, but I'm going to stop here in this video. You guys got enough stuff to watch, but if you want more, you're going to have to request it. Go study.